Similar triangles on Math Visions. Similar triangles have matching angle measurements and the same shape, but they may be different sizes. Therefore, they're not congruent. The following rules only apply to fully enclosed, three-sided shapes. To determine similarity, you need to know at least two angle measurements, or the length of all three sides, from each triangle. We have triangle ABC, in which angle A is 56 degrees and angle C is 78 degrees. To the right of it is triangle QRS, in which angle R is 46 degrees and angle S is 56 degrees. If we had the measurements of all three angles, and the triangles still only had one angle in common, we could write these triangles off as not being similar. However, we only have two angle measurements from each triangle. Since the sum of all three angles in any triangle is always 180 degrees, we can subtract the measurements of the angles we do know so as to find the measurement of the angle we don't know. For triangle ABC, we start with 180 and subtract 56, then 78, and arrive at a measurement of 46 degrees for angle B. If you noticed, 46 is also a measurement from the other triangle, QRS. Since both triangles have two angles in common, 46 and 56 degrees, we know they're similar. We can prove this by subtracting the measurements of angles R and S, 46 and 56 respectively, from 180. We see that 180 minus 46 minus 56 equals 78. Now it's easier to see that if two angles match, the third angle will indeed match, since we now see that both triangles have angles measuring 78, 56, and 46 degrees. If we rotate triangle QRS like so, it's now easier to see it is similar to ABC. Now, for triangles DEF and WXY, I've marked the line segments by the longest, 3 marks, mid-length, 2 marks, and shortest, 1 mark on each triangle. Though the lengths are different, we can divide the length of the corresponding lines on WXY by those of DEF. If the quotient for each set of lines is the same, we know our triangles are similar. If even one quotient is different, the triangles are not similar. Let's start by dividing the length of line segment WY by that of EF, since they are the longest segment of their respective triangles. When we plug in the respective lengths, we get 21 divided by 7, which is 3. When we complete our division, we see that each set of corresponding line segments has a quotient of 3. Therefore, we have similarity. Again, placing the triangles in the same orientation, it is much easier to visualize the similarity. Well, that's a wrap for me. Thanks for watching. Don't forget to check out my knowledge building exercises, link below in the description. I look forward to meeting with you right here next time on Math Visions.